Good afternoon, everyone. Please be seated. माइक का बता देना मुझे. ओके. Okay, so online people, just let me know if I'm audible. Okay, so those of you who have joined through Zoom, just drop a message, or you can speak also by unmuting yourself if I'm audible, so that like we can begin the discussion today. Okay, Zoom. Okay, all right, thank you so much. So, hello everyone, welcome to Lukmaan IAS. Basically, let's say today it is your first session on GS Foundation batch. Most of you have started your journey to prepare for the UPSC Civil Services examination. And Lukmaan IAS is a very trusted institution. It has been there since last 13 years. And the institution has been established by S Ansari sir. He is a faculty of the institute. He is a senior faculty. He's been teaching, let's say, Indian polity, ethics, and public administration optional subject. So today we are beginning the discussion on general studies with science and technology as a subject. So the thing is, in this journey we are going to have discussion for about 5 days, and in the initial 5 days the classes will be taken by different faculties every day. So they are going to introduce about their subject, right? So it's going to be an introductory class, and after 5 days from 22nd January onward we are going to have Indian economy subject. All right. So today we are going to discuss science and technology as a subject. We will understand the nature of this subject. We will understand what you need to learn in science and technology, and why science and technology is there in UPSC syllabus. You are preparing for let's say general services. Why science and technology is there, we will understand. We will understand the nature of the subject. We will understand what are the syllabus in this subject, what you need to study in this subject. We will understand about the recent trend in the papers. We are going to understand about some of the sources that you need to let's say follow to understand this subject holistically. So this science and technology section is going to be really interesting once we start the discussion. But the thing is, today we are going to have a general overview session, and in today's session I'll take you through different sections of the science and technology. We are going to discuss about the space science and technology. We are going to discuss about nanotechnology. We are going to discuss about nuclear science and technology. We'll discuss about defense technology. We will discuss about biotechnology. We are going to discuss about various areas areas of science and technology. All right. So this is the thing. So when we talk about science and technology as a subject, right, this particular subject is important in specifically 3 areas. What are 3 areas? Number 1, it is important for the prelims exam of the UPSC Civil Services exam. Why? Because in the prelims exam they ask about 15 questions every year. 10 to 15 questions are asked in the prelims exam itself. So in prelims there is a weightage of 10 to 15% of the science and technology itself. Then when we talk about the mains exam, in mains exam we have various general studies papers, right? We have, let's say, the essay paper, we have 4 general studies paper. Then you also have this optional subject. You need to select one optional subject for each of you. You need to select one optional, and on the basis of one optional there will be 2 papers. There will be 2, let's say, optional subject papers. Apart from this, you need to, let's say, learn 2 languages. One language, let's say, will be English, which is compulsory. The second language will be chosen by you as part of, let's say, 8th schedule of the Constitution. There they have mentioned 22 languages in all. So one of those languages will be considered, let's say, like, by you to appear in the exam. So that's the thing. So we will discuss about the exam pattern also. We'll discuss about what mindset, what mentality takes you through the exam. There are many students who are putting effort, right? And most of you who enter into the preparation, they put effort to qualify the exam. But some of the candidates are able to qualify the exam. So there are some, let's say, like, different things that the toppers are doing, right? Means like they are reading the same subjects, they are reading the same syllabus, but they are preparing in a different manner. We are going to discuss about that preparation strategy also, right? And in the GS Foundation batch, let's say I will be the mentor for all of you throughout the year. Let's say I'll be there to help you related to any subject that you face difficulty, any technical errors that you face, all of those things, let's say, like, you can reach out to me. Apart from this, we have many faculties in the GS Foundation batch. Those faculties will be teaching their own respective subjects, right? As per the schedule that will be provided by the institute. So let us discuss about science and technology as a subject, right? So as I discussed, this particular subject is relevant for 3 areas. Number 1, this subject is relevant for the prelims exam, right? This is relevant for the UPSC mains exam, and this is also relevant for the personality test. What? It is also relevant or important for the personality test. In general, we know it as interview, right? In interview. So recently, we are in Lukmaan IAS, we are also conducting mock interviews. We are providing interview guidance program to the students. Recently, one student came, he appeared in mock interview. One of the board member has asked him, what is the difference between the, let's say, Newton's, theories of gravitation and the theories that were given by Albert Einstein. So that student was not able to answer this question. He was not able to answer what is the difference between the, let's say, Newtonian law, right, and the laws that were postulated by Albert Einstein. He was not able to answer that. And apart from this, they ask multiple questions in the interview also related to science and technology. So it is important that whenever you start your preparation for science and technology, right, don't go for learning only the factual things. Means it is important for you to understand the subject in a holistic manner, learn the concepts behind them, and whenever something is in news, learn about that thing as well. So this is the thing. So this science and technology is important for the prelims, as I discussed. It has a weightage of about 10 to 15% in the prelims exam. Okay, 10 to 15 questions are asked. It is important under GS paper 3 of the mains exam. Which paper? GS paper 3. In GS paper 3, there are multiple sections: Indian economy, science and technology, environment and ecology, internal security, disaster management. These are the areas of GS paper 3, right? So in GS paper 3, science and technology is a section of the mains exam. So UPSC asks questions that has a weightage of about 50 marks in the GS paper. It has a weightage of about 50 marks. And what is the weightage of every GS paper in the mains exam? The weightage is 250 marks. So when we talk about 50 out of 250. So this is what percentage? 20%. So 20% weightage is there of this subject in the mains exam. It has a weightage of 10 to 15% in the prelims exam. If 10 questions are coming, 20 marks questions are coming. 15 questions, so 30 marks questions are coming. It is a very important section of the entire UPSC preparation. It is a very important, let's say, section. So we will understand about the nature of this subject. Means like, what is the standard of questions that are asked by UPSC from this area? What do they expect? And before that, we will also learn that why science and technology is read by you, why it is important. Basically, if I ask a question, tell me the event that has led to the ending of World War II. What has led to the ending of World War II? What incident or event has led to ending of World War II? Yes.
Collapse of USSR and disintegration of USSR and rise of
Okay, so she has tried to answer. So she is saying collapse of USSR. USSR has collapsed in 1991. The World War II has ended in 1945. It has started in 1939, ended in 1945. So long back, World War II has ended. Okay, so that answer is not reasonable, right? Yes, you were answering something.
Bombardment on Japan by America, the atomic bomb on Hiroshima and Nagasaki.
The atomic bomb on Hiroshima and Nagasaki. He has said this. Yes, any answer from online people, whosoever are attending the class online? So what event has led to the ending of World War II? This is a general question. I mean, like, so it's like that. All right. So let me talk about this. Basically, during World War II, the Allied powers, right? Allied powers were fearful of the Central powers. Central powers constituted the Germany, it constituted Italy, it constituted Japan. Allied powers had the USA, United States of America, UK and USSR as part of it. Okay, so these were the Allied powers. So Allied powers were fearful that Germany is building some atomic bomb. It is building nuclear bomb. So the thing is, they have started a project. Who? The Allied powers. United States of America has started a project. So this is just for general understanding. Name of that project is known as Manhattan Project. Name of this project is known as Manhattan Project. And this Manhattan Project was led by a scientist. You might have heard about his name, Robert J. Oppenheimer. In short, we know him as Oppenheimer. Recently, there was a movie also, Oppenheimer movie, right? So, for the first time in the world, the atomic bomb was developed by United States of America, and they have, let's say, like, initially what has happened, Germany has already surrendered, right? I mean, like, in May, I think in the May, it has surrendered to the Allied powers. But when we talk about Japan, Japan was not surrendering. It is a very small nation, but it's a very powerful nation. They have also captured the Manchurian region. So the thing is, what has happened, like this project was started in 1939 by USA under Robert J. Oppenheimer, Mr. Oppenheimer. And the thing is, there were many other scientists also. And this project was started in 1939. And 1945, let's say, they have done a testing also. And they have done the testing of atomic bomb in New Mexico. After then, they have launched this atomic bomb. Okay, this is just for your general understanding. They have launched this atomic bomb on two places. One of the places is known as Hiroshima, and the other place is known as Nagasaki. And these two places are in Japan. In Hiroshima, they have, let's say, launched this thing on 6th of August. Dropped this bomb in 6th of August 1945. In Nagasaki, they have dropped this bomb on 9th August 1945. Right? The bomb that they have, let's say, like dropped on Hiroshima, this bomb is known as Little Boy. It is known as Little Boy. And the bomb that they have dropped on Nagasaki, it is known as Fat Man. What? It is known as Fat Man. Why it is known as Little Boy? Because the nature of bomb that they have launched, they have, let's say, like, dropped on Hiroshima was different than the one that they have dropped over here. So under this Manhattan Project, they have developed atom bomb that used, let's say, uranium 235. Uranium 235. And here they have used plutonium 239 to create this bomb. So the nature of this uranium 235 is known as Little Boy, and this is known as Fat Man. So basically what has happened in the World War II, around 70 to 85 million people have been killed. But after launching these bombs in Japan, around 1,29,000 people too, let's say, like, 2,80,000 people have been killed. Right? After then, Japan has surrendered. So the thing is, the World War II was stopped because of atom bomb, because of nuclear bombs that have been, in the history of the world, this has been for the first time that United States of America has used atom bomb against any country. And after then what has happened, the countries have decided that, we will stop the world from going any further, going into any further world war. So they have created United Nations organization, we have United Nations Security Council, and now also various wars are happening. But different countries have acquired nuclear weapons. Why they have acquired nuclear weapons? They have acquired nuclear weapons not to attack on someone. Their first thing is to create deterrence measure. Means they want to develop their capacity so much that no other country should think of attacking on them. If they attack on a country that possesses nuclear weapon, they will retaliate on that country and they will also use nuclear weapon, and it will hardly take 60 seconds or a minute. Means a country that possesses nuclear weapon, that country is strong enough to defend itself against any threat of usage of nuclear weapon. For that purpose, there is an arms race among different countries. They want to possess nuclear weapons. This is one of the story. You are understanding? So that helps us to understand that why nuclear bombs are made. People make and acquire nuclear weapons to defend their country, to defend their sovereignty. At the same time, there is an arms race because countries want to have their stronghold, let's say, like in international power. So power is of two types, hard power, soft power. Hard power means, like, if you have military capacity, if you have economic strength, they are pillars of hard power. Soft power means using diplomacy. That's the thing. So those countries who are focusing on developing their hard power, they acquire, let's say, weapons of different types. They become economically stronger. Now if we talk about North Korea, North Korea is a very small country. Why no country is attacking on North Korea? Because North Korea has acquired nuclear weapons. It is a nuclear weapon state. It threatens the United States of America also. That don't think of attacking on us, otherwise we are going to launch nuclear weapon to your country. They have developed intercontinental ballistic missile as well. So when we talk about intercontinental ballistic missile, we will learn about the ballistic missiles, we will learn about different types of missiles, we will learn about cruise missiles, ballistic missiles, difference between them. So this is a kind of missile technology, right? So why missiles are important? They are important for defending a country, right? They are important for defending a country. And can you tell me who is known as the missile man of India? Dr. APJ Abdul Kalam Azad is known as missile man of India. Why missiles are needed by a country? So that we can defend ourselves. The first important priority is, let's say like we want to defend ourselves. So that's why we want to learn about defense technology. So we will understand about, let's say, missiles, we will understand about submarines, we will understand about, let's say like, different kind of weapons that are being developed, right? We will understand about nuclear command authority. We'll understand about nuclear weapons. Nuclear weapons are known as dual use technology weapons, okay? They are known as dual use technology weapons, that's the thing. Okay, so this is the thing that why we are learning about this. Apart from this, let's say like all of us understand about this particular thing, that Earth is a geomagnet. Do you know what is geomagnet? Let's say this is Earth, right? This is Earth. So Earth has a north pole, it has a south pole, you know. These are known as geographical north or geographical south. They are known as true north or true south. So here, over here, we have north pole. Over here, we have south pole, right? This is known as true north, true south, north pole. So Earth can be divided into two major halves. The northern half is known as northern hemisphere. The southern half is known as southern hemisphere, right? So North Pole and South Pole are important geographically, but apart from this, we do have other poles also. They are known as, let's say like, this is known as magnetic North Pole, and then we have magnetic South Pole. Magnetic North Pole, magnetic South Pole. Why we need to understand about magnetism of the Earth? To understand this thing, you need to understand. Recently, let's say like, the Indian Space Research Organization, you might have heard about the name of this organization, which is known as ISRO, Indian Space Research Organization. They have launched a project, it is known as Aditya L1. What? Aditya L1. Have any one of you heard about this name, Aditya L1? Right? We have heard about it. What is this mission all about? This mission is a solar mission. We want to study the sun. What we want to study in sun? We want to study about the composition of sun. We want to study about the magnetic, let's say like emissions that are done by sun. So there are, let's say like, some kind of magnetic flames arising from the sun. We want to study about that. Why it is important? Why India is interested in learning about sun? It has various, let's say like, various connotations. Why? Because the thing is, Indian Space Research Organization is one of the growing space research organization in the world. India is a large spacefaring nation. In the world, we do have various space, let's say, agencies. For example, if we talk about NASA. NASA, what is the full form of NASA? National Aeronautics and Space Administration. This is the space agency of the United States of America. When we talk about Roscosmos, this is the space agency of Russia. When we talk about JAXA, this is the space agency of Japan. So there are, we have Canadian Space Agency, we have European Space Agency. So different countries have their own space agency. And what is the role of the space agency? Role of the space agency is to do space exploration. In India also, we started space exploration long back. When? Like who is considered to be the father of the space program in the country? Vikram Sarabhai. And any other name that you can think of? Vikram Sarabhai, then later on Satish Dhawan, right? Then Homi Jahangir Bhabha, he was associated with the atomic energy. Right, so we have Bhabha Atomic Research Center, BARC. It is known as what? BARC, Bhabha Atomic Research Center. So he was associated with atomic energy. So who has started the space program in India? Vikram Sarabhai. So we have Vikram Sarabhai Space Center, from where we launch satellites. And we will understand in our discussion that why we select let's say coastal locations as the location for launching the satellite. There are scientific reasons for this. There are scientific reasons to understand that thing. So here we were understanding about Aditya L1. So we want to study about the sun. Why? Because sun emits What? It emits magnetic waves, it emits magnetic flares. We receive sunlight every day, but apart from this, magnetic flares are also coming. But those magnetic flares are not coming on the surface of the earth because it is protected. It is protected by earth as a magnet. Earth also acts as a magnet, it acts as a geomagnet. We will understand about geomagnet of the earth. So because earth acts as a geomagnet, it protects, it shields the surface of the earth from any magnetic flares that are coming. So like when you read geography, you will understand about, for example, aurora borealis. You will understand about aurora australis, like that. So these are magnetic flares. So what happens on the, let's say, top of the environment, let's say like, on the top of the environment there, atmosphere, many, let's say like, lighting activity can be seen, right? Those are aurora borealis, aurora australis. What are these? Borealis happens on the northern hemisphere, australis happen on the southern hemisphere. And these are because of the interaction between magnetic waves that are emitted by the sun and the magnetic waves of the earth. That's the thing. So that's why we study about magnetism of the earth also. And these make potential questions in the UPSC examination. Right? These makes potential question. We will understand in detail. Today is just introductory class. I'm not making you write down notes, but I'm making you understand how we are understanding the science and technology as a subject. So we need to understand why we are reading a topic. That's the thing. And after then we need to understand about the core concepts behind them. Right? You don't need to learn only the factual information that is there. Learn why it is there, how it is being done, who is doing, what is the purpose, what we need to learn. Is it going to come in the examination or not? So that way you will be able to understand the things properly. Okay. So shall I explain the magnetism of the earth so that you get little clear? Okay. So let's discuss about this particular topic. So let me draw earth. Okay. So along with this you may draw earth. Let's say this is the map of earth, and here we have, let's say, north pole. We have the south pole. The north pole is known as true north. This north pole is geographical north pole. Okay, this is known as true north and true south. Apart from this, we also have magnetic north pole and magnetic south pole. Okay, like we have magnetic north pole and we have magnetic south pole. So to understand about the magnetism of earth, I will make you first understand about the magnet. What do we mean by magnet? Okay, so before we move into this, because like you need to understand this thing. So let's say this is a magnet. We all know that magnet exists as two poles. I mean, like, we do have north pole of the magnet and we will be having a south pole of the magnet. What is north pole and south pole? Okay, magnet has two poles. So magnets has two poles, like it has north pole and south pole. Magnet always exists in two poles. If you break this magnet into two different halves, if you make it half, then also it will be having a north pole and a south pole. If you again break it, no matter how small you are making a magnet, the magnet will always be having two poles, right? So magnet always exists in a state which is known as dipole. What? It is known as dipole. Dipole means it has a north pole and it has a south pole. Always, all magnets that you can see, they have only, let's say they always have two poles. And the thing is, from these magnets arises something, these are known as magnetic field lines. So I'm just drawing some lines over here, like this. Okay. The lines that I have drawn over here, these are known as magnetic field lines. So the thing is, from north pole arises the like magnet. So these are magnetic field lines around a magnet. Why magnetic field lines? So the thing is, If you have this magnet, if you have another magnet, a small magnet, that small magnet will either get attracted to this magnet or it will get repelled if it comes in the influence of magnetic field lines. Alright, if it comes in the influence of magnetic field lines. So where we have the strongest magnetic field line? At the poles, in North Pole and in South Pole, wherever we have more number of magnetic field lines, right, congested with one another, there we will be having a stronger magnetic field. The place where we have less density of the field lines, we will be having less strength of the magnetic field. Are you understanding? So the number of magnetic field lines that are closely spaced with one another, it is there in the poles, North Pole and South Pole. Magnetic field line originate in the North Pole and it go in the South Pole. And magnetic field lines are continuous lines. Continuous means they do not break. Means like after, so it has arisen over here, it has gone, and inside also it will be like this. Inside also it will be like this. Okay, they are continuous lines, they do not break. Apart from this, magnetic field lines have another property. That property is known as magnetic field lines do not intersect with one another. Intersection means, let's say you have one line, you have another line. So there is a point of crossing. In magnetic field line, that crossing does not happen. I have drawn a rough diagram, so you may see some crossing, but actually in magnetic field lines, no crossing will be there. No intersection happens in magnetic field lines. So this is known as what? Magnetic field lines. Okay, this particular apparatus is known as a bar magnet. What? It is known as bar magnet. So what properties does it have? What properties did I talk about? The strength of the magnetic field line is highest at the poles and it is least over here in the middle somewhere, because they are spaced from one another. Magnetic field lines are continuous field lines. They originate in the North Pole, they go in the South Pole. Magnet always exists in dipolar format, means always they will be having two poles. Yeah, no matter how small we are making it, always magnets will be having two poles. That's the thing. And since you have understood this thing, now you will be able to understand this thing as well. Okay. Now let us move back to this discussion. So any doubt in understanding the magnets? Okay. So now let us understand this factor. Now, so we have understood this particular thing that we have North Pole, we have South Pole. This is geographical North, geographical South. And here we have a line, this is known as equator. Equator of the earth. This is 0 degree latitude. But when we talk about this magnet, earth acts as a magnet, so the thing is the magnetic field lines in the earth will be originating from where? The magnetic field lines will be originating from the North Pole. They will be going to the South Pole. Like that. So our earth, this earth acts as a geomagnet. Earth acts as a geomagnet. So earth is also a kind of magnet in itself. Why earth is a magnet? There are scientific reasons also related to it. We will understand that thing as well. So have we understood that earth acts as a magnet? So here we will be having magnetic field lines. And the thing is, when we talk about those people who went for exploration, Columbus, you might have heard about Columbus. So, Columbus went for exploration. Which continent did he want to search? He wanted to search India. Where he actually landed? America. Why the distinction? I mean, which country did he come from? One of the country in Europe, yes. So, yes, these have been the people who have been the explorers. For example, when we talk about Columbus, so the thing is, there are stories associated with him. We will discuss in later part. So the thing is, he went for exploration. He wanted to, let's say, discover India. He wanted to get riches from India. He wanted to get it back to the country where he was residing. That's the thing. But he landed somewhere else. Why? Because the thing is, the compass that they were using, right? They did not know that, how the calibration of the compass happens. They did not know, in what direction it is going to showcase. So the thing is, when we talk about geographical north and south pole of the earth, they remain intact. They are there itself. Geographical north pole will be here itself. Geographical south pole will be here itself. It is exactly, let's say exactly perpendicular to this equatorial line. But when we talk about magnetic north pole is little bit declined or inclined from the geographical north and south pole. And why this declination is there? Does the magnetic north pole and south pole remain where it is now? No. It keeps on shifting. The magnetic north pole and south pole, it keeps on shifting. It shifts, let's say little here, little there, but that shift does not happen rapidly. It happens over a long period of time, means like hundreds of years, millions of years, like that. Okay, means magnetic north pole and south pole, they shift. And here we need to understand that here, let us understand this particular factor, that let's consider from the north pole, from the true north to the geographical, to the magnetic north, there is an angle that it is making. Let's say this angle is phi. This angle is phi. What this angle is known as? This angle is known as declination. What? This is known as declination, not inclination, it is known as declination. So the thing is, if magnetic north pole is, this is the west side, this is the eastern side of the earth, like if we talk about this, right, we have east, west, north, south. These are the four cardinal directions, right? If we go this direction, this is east. If we go this direction, this is west, this is north, this is south. So the thing is, if this declination is towards the west, we will be using negative. This is known as negative theta, whatever angle is there. So if, let's say magnetic north pole comes over here, in that case, if it is in the eastern direction, we will be using positive theta, like that. Okay. Magnetic declination towards left, and this. Apart from this, there is another thing which is known as equator of the let's say geomagnet. What? Equator of the geomagnet. What is equator of the geomagnet? When we talk about this is magnet, so this will be the equator of the geomagnet. So you need to draw some, I'll be using some other color. Let's say I'm using green. This is the equator of the geomagnet. This is the equator, okay? So Earth acts as a magnet, Earth itself acts as a magnet. So the thing is, when we talk about this is north pole, internally it will be little different. This is magnetic south pole, this is magnetic north pole. Internally what will be having, see, field lines are coming over here, but from internal it is going that direction, okay? Internally, this is the magnetic north pole, okay, magnetic north pole, and this is the magnetic south pole. So the thing is, magnet will always exist in dipolar format, okay? This is the thing. Apart from this, there are many other things also associated with this. Now, after discussing all of it, you understood that Earth acts as a magnet, similar to this magnet. But what gives the magnetic characteristic to the Earth? Means like, how does Earth acquire magnetism? What is the reason? To understand how does Earth acquire magnetism, you need to understand that the thing is, if we talk about the core of the Earth, if we talk about core of the Earth, in different colors, you might have heard about the, let's say, geology of the Earth, right? We have core, we have mantle, lower mantle, upper mantle and all. So in the mantle, in the core, let's say like what we have molten form of metallic thing. So inside here, let's say we have Fe plus Ni. Fe means iron and nickel. And these iron and nickel are in molten format. And they are in molten format and they are not static, they are moving. So we do have convectional current. The current when they move, right? So their ions are there, since they are moving. So the thing is, they create convectional current. And the thing is, Michael Faraday has given, let's say, this particular thing, then whenever there is movement of current, it will also lead to magnetic field. Current and magnetism are associated with one another. Since the molten material, iron, nickel, they are moving inside the earth, it is giving magnetic characteristics to the earth. Okay, it is giving magnetic characteristic to the earth. So why earth has magnetic characteristic? It is because of this particular factor. Which factor? This factor. This is the thing. That it does have molten material inside it. So this is the thing. That's why when we talk about Aditya L1 mission, the Aditya L1 mission, yes.
How is it creating a current, like electric current they are creating?
Yes.
Movement of metals is creating.
Movement of molten metal inside the earth. It leads to kind of convectional current. Okay, electric current are being generated inside. And because of movement of it, magnetic fields are arising. Okay, magnetic fields are arising. Okay, so for that, let's say, you need to understand flux, magnetic flux. So magnetic flux is, let's say this is a magnet, bar magnet, it is kept over here. Right, this magnet has been kept over here. If we don't move the magnet, it will be like this. But the thing is, if we have an apparatus over here, let's say if we have an apparatus that's able to measure the electric current, let's say I, this is the apparatus. What will happen? If we move this thing here and this is kind of coil that is associated, let's say if I make the coil in this direction, like that, okay. So if we move this magnet near the coil and if we bring it back, so number of field lines that touches this coil will vary. Initially it is 0, then 1, 2, 3, 4, like that, it will vary. And because of movement of these magnetic field lines, it generates, let's say, current. The magnet generates current, and using current we can generate magnetism also. So this is Faraday, Michael Faraday has given, let's say, law related to this, right? So the shifting of the magnetic field line is known as magnetic flux. What it is known as magnetic flux, basically. Okay, so that's the thing. Yes, you want to ask something?
Yes, sir.
Okay, all right. So this is just to understand, and when we talk about Aditya L1 mission, there are many things. So what is L1, Legrange point? I mean, so Legrange points are points of stability. So in UPSC, what they ask is, everybody knows that ISRO has launched Aditya L1. But people don't study much. They don't go deeper to understand this. UPSC may ask, right? UPSC may ask, what are Trojan points? What? Trojan points. But candidates like you or who are just starting their preparation, if you don't have a proper guidance to understand the thing, you will not be knowing what are Trojan points. To understand this, you need to have a deeper understanding of the topic. Let me make you clear to, that topic. To understand this, for example, let's say this is Earth. Here we have Earth, right? And somewhere here, let's say we have the sun. From sun we are receiving sunlight. The Aditya L1 that we have launched from Earth, we have launched a spacecraft that's going to go somewhere here. Let's say this is the point which is going to reach. This point is known as L1 point. So there are many similar points, 5 points between two heavenly bodies like this. L1 point is lying between these two bodies, Earth and Sun. Then L2 point will be, let's say, just located to the opposite of Earth. Let's say this is L2. L3 point will be lying over here. Where? L3, opposite to the Sun, right? Then there will be another point which will be known as L4. Then there will be a point which is known as L5. So what are these points? Why we are talking about these points? These points are known as Legrange points. These are known as Legrange points. So here what we are understanding, the topic quickly, okay, like we are not understanding in detail about this. This is just an introduction. We are understanding about Aditya L1. So this Aditya L1 mission has been launched by which organization? Indian Space Research Organization. So ISRO is the, let's say, like, you know, Space Research Organization of India, right? So Aditya L1, we are talking about this. We have launched a spacecraft which is known as Aditya L1. It's going to reach over here in this point L1. It is going to stay in space. Means like it is going to stay over here and it is going to follow a orbit. This is known as halo orbit. We are going to understand about this. How far is this distance from Earth? This distance from Earth to L1 point is 15 lakh kilometer. How much? 15 lakh kilometer. It is also can be considered as 1.5 million kilometer. How much? 1.5 million kilometer from here. And if we compare this distance with the overall distance from Earth to Sun, how much is this distance? This distance is just 1%, and this is 99% of the distance between Earth and Sun. Are you understanding? This is just 1% of the distance. And this particular distance, if we compare this distance with the distance of the Moon, let's say this is Earth, somewhere we also have Moon. Let me draw Earth, let's say using another color, because like Earth is a planet having water, so I have drawn blue color. So we will draw now Moon. Let me draw Moon using another color. Let me take this color. Let's say this is the location of Moon. Right? So whatever distance that is there between Earth and Moon, this distance is 4 times of this distance. Okay, this is around 3,80,000 kilometer. So this is around 4 times of this distance. This is, let's say, x. This distance is x. So this distance will be 4x. Are we understanding? So this is the thing. So what is L1? We need to understand what is L1. Like between these two bodies, there exist 5 Legrange points. L1 is known as Legrange point 1. Why Legrange point 1? Legrange point 1, here if we bring a spacecraft, if we bring some spacecraft from outside, so the thing is, we know about theory of gravitation. Albert Einstein said that the thing is every body in the universe is attracted by every other body by a force which is equal to G m1 m2 upon r square. Means like between two bodies there exists a force which is G m1 m2 upon r square. Sorry, Newton, Isaac Newton has given this thing, theory of gravitation. He said, for example, we are on the surface of Earth, we are being attracted by Earth. That's why even if we, let's say, jump above, we'll be coming down. If we talk about the gravitation that we have on the surface of Moon, this is 1/6 of the total gravitation. Here we have 9.8 meter per second square. There it will be 1/6 of the gravitation. Means like the force that we are applying over here to jump. In Moon, if we apply the same force, we will be going 6 times higher. Right? If you are going, let's say, like 2 meter, there you will be going maybe 12 meter using the same force. That's the thing. So here, so if there is a body over here, it will be attracted by Earth. It will fall down on Earth. And let's say if there is a body nearby Sun, it will be attracted by the Sun. There is a place between Earth and Sun where the force of attraction by Earth and the force of attraction, let's say force of attraction by Earth and force of attraction by Sun, they will balance out one another. These two forces will balance out one another. Tidal forces will also balance out one another. And the object that is coming over here, object means spacecraft satellite that is coming over here. This object over here will be in a kind of a stable equilibrium. Means it will be able to stay there without using much fuel. Okay. The kind of equilibrium or stability of these points are relative with one another. Some of these points are highly stable, some of these points are less stable with one another. When we talk about L1, it is relatively a less stable point. right? L1 is, let's say like L1 is more stable than L2. Then like we have L3, which is little less stable. But L4 and L5 points, they are known as the highly stable points, okay? L4 and L5, they are known as Trojan points. What? They are known as Trojan points. T-R-O-Z-A or J-A, you see it, right? They are the highly stable points between these two bodies, okay, Earth and Sun. They are the highly stable. These 2 points are the most stable points, right? So L1 is not the most stable point. But why we have chosen L1? Because L1 is directly in line of sight with the Sun. So Earth is revolving around the Sun, we know it is revolving, right? So Earth is revolving, this point will also follow the Earth and it is going to make an orbit that's known as halo orbit, right? This is known as halo orbit. Earth is revolving, so Earth is not going to come between L1 and Sun. Okay, so this point is not going to see any kind of eclipse, solar eclipse, it's not going to see. Are you understanding? Means like if Earth comes over here, so it's going to obstruct the visibility of the Sun. That's going to create solar eclipse, means like Sun will not be visible like that. So that's why this point has been chosen. If we choose L2 point, from here studying the Sun will be difficult because Earth is going to come in the middle. This point is very far located, that's also difficult, so that's why we have chosen this point. Okay, so that way we need to understand science and technology. Any topic that is coming in news, they are important, and the thing is the fundamental ideas, fundamental concepts are also important, right? UPSC, let's say, assumes us to be well-read people. Well-read means you should understand whatever there is in news, especially science and technology, polity, international relations. It is very important, okay? Means like those topics that are in news, you need to understand. And in the Constitution of India itself, right, in the, let's say like, fundamental duties, they have mentioned that human beings, like citizens of India, must develop scientific temper. They have mentioned in the, let's say like, in DPSPs also, in fundamental duties also, that like, we need to develop scientific temper, right? Scientific temper is needed more in, from the civil servants. This is the thing, because India has been a, let's say, very, ancient civilization. Being ancient civilization, there are many practices in this society that are happening. Superstition used to happen long back. It is important that we need to, let's say, question everything that is there. Like there should be rational understanding of the things. So that's why it is important that we develop scientific tempers, we need to understand. So when we talk about the nature of the science and technology subject, okay, let us understand about nature of this subject. We are going to discuss one aspect at a time, right? Nature of science and technology subject. So, nature means the direction in which UPSC is asking question, right? So that makes the nature, like why we need to read this subject. Nature of this subject is that it demands, this particular subject demands curiosity in mind. Curiosity. For example, anything that comes up in news related to science and technology, you should be curious enough to learn about it. If you are curious enough to learn about it, you will be learning new things that are coming. In science and technology, discoveries happen, inventions happen. People are always trying to develop new technology, innovative ways of solving the existing problems. In this society, the problems that we have now, similar problems existed thousands of years back also. But the thing is, human beings have come up with one or other solution to address those problems. Long back, people did not have agricultural system. What they did, they started using the stone tools. They started using stone tools for, let's say, like going for agricultural practices. They created fire out of it. Slowly and gradually, the society has moved so much, we have become so much advanced that nowadays we learn about artificial intelligence. Nowadays we learn about machine learning. we talk about quantum mechanics, we talk about quantum physics, right? We talk about new areas. So research is happening, discoveries are happening, right? And why it is important that we keep learning new things. If we keep learning new things, we will stay relevant with the times. If you are a civil servant, you go into the services, initially what will happen, you will be, let's say, like, you will be knowing what is happening in the society, but down the line after 10 years, if you stop reading, you will not be, let's say, having the latest knowledge, you will be not be updated. If you are not updated, if you do not have latest knowledge, it will be reflected in your communication. It will be reflected in the, let's say, interaction that you have with the people. So the thing is, it is important that reading, learning should be made as part of your life. Not only for UPSC preparation, but you keep on learning so that, like, there should be a lifelong learning. For example, people, like, people who are professors, people who are scholars, people who are diplomats, people who are politicians, they are the ones who continuously keep learning, they continuously keep reading. They are lifelong learners. You always have to be a student to stay ahead of time or to stay relevant with time. It is important. So curiosity is one of the important factors whenever you are learning science and technology. Okay, you need to learn about the basic sciences first. Why basic sciences? So that you understand the fundamental principles behind the things. If you learn the basic sciences, then you need to augment that basic learning with the new things that are in news. And if you see past 10 years, 15 years paper of UPSC, the thing that were in news that time, the thing that were invented that time, they were asked by UPSC. But is UPSC going to ask the same question that it has asked 10 years back? It's going to ask about, let's say, like, the kind of clock that we used to have in digital watches. No. The thing is, things are changing. New things are being invented. And UPSC is interested in checking your understanding related to new things. So the thing is, you need to learn the latest developments. Okay. If you see the UPSC syllabus of mains exam, right? Syllabus has 3-4 points in the mains exam that talks about, let's say, developments and applications of science and technology in daily life. This is part of the syllabus. It talks about that you need to learn about developments and application of science and technology in daily life. It also asks about, let's say, indigenization of technology, developing new technology, like, and the scientists of India. Why I talk about scientists? Because, like, UPSC does ask questions from scientists. They have asked questions related to many scientists. They have asked about, for example, M. Vishveshwarya. In UPSC mains exam, they have asked a question related to this. And if you talk about current relevance, recently Chandrayaan 3, all of us know about it. It made national sensation, national news, because India was the first country to have landed its spacecraft on the south pole of the moon. Right? We have landed our spacecraft Chandrayaan 3 on the south pole of the moon. So this was an achievement for the country. And when it came in news, I have discussed this thing in the classroom. And the thing is, same thing came in the UPSC mains exam. There was a question, 15 marks question. They have asked multiple things related to it. That what is this, let's say, India's moon mission, right? Chandrayaan mission is moon mission. They have asked about the components of this mission. Components means they have asked about the subsystems of this mission, right? They have asked about what is India's objective of, what are the objectives of Chandrayaan 3. Objectives, what were the objectives? We wanted to demonstrate soft landing capacity on the surface of the moon. We want to land on the south pole of the moon. We wanted to demonstrate that rover, let's say, roving on the surface of the moon, traveling on the surface of the moon. Rover wanted to, let's say, like, collect the samples and do in situ analysis, like that. And the Aditya L1 that we discussed about, it also has 7 scientific payloads, 7 scientific instruments in it. So you need to learn about those scientific instruments, which scientific instrument is doing what, because day before yesterday or before that it was in news. So when we talk about science and technology as a subject, you need to learn about the fundamental aspects, basic aspects of the subject. After then, you need to keep learning from the current affairs also, because current affairs are very relevant. The nature of this subject is like this. Science and technology is like this. Okay. So it demands curiosity, it demands basic understanding. This subject demands basic understanding, and this subject also demands the, let's say, like, latest development. Okay, so you need to learn about developments that are happening in this area, right? Developments and applications. So whenever you come across any question in the prelims exam, either they are from the very basic concepts, like what is the difference between eukaryotic cell and prokaryotic cell, or they are from the application areas. For example, they have asked, like, the application of drone technology lie in the following areas. It can collect, let's say, like, whales samples, whales sprout, it can collect samples from there or not. So the thing is, any technology that is in news, you need to understand that in which areas this technology has or finds its application. That's important. Okay, it demands, this subject demands this particular thing. Okay, so developments and application means you need to learn about the current affairs. When we talk about basic understanding, how you can develop basic understanding? To develop basic understanding, you need to read NCERT books. Okay, what? You need to read NCERT books to develop basic understanding. And when we talk about to learn this particular developments and applications, you need to read current affairs. Don't read only from the newspaper. Apart from newspaper, current affairs can be read from newspapers, right? They can be read from newspapers. Apart from newspapers, you need to follow the websites of the ministries, of the departments, of the agencies that are in news. For example, recently, okay, so here I am writing, you need to learn from the websites of ministries or agencies. That's the thing. Okay. Why websites of ministries and agencies? For example, recently Deep Ocean Mission was in news. Deep Ocean Mission. So this belongs to which ministry? Deep Ocean Mission. Deep Ocean Mission belongs to Ministry of Earth Sciences. Which ministry? Ministry of Earth Sciences. Go to the website of Ministry of Earth Sciences, learn about Deep Ocean Mission, learn about the objectives of this mission, learn about various things associated with this mission, right? What we are going to do. Under Deep Ocean Mission, what we want to do, we want to send a capsule, right, under the ocean. So we want to send a capsule under the ocean, and it is planned that human beings will be sent very deep under the ocean. From there, they want to collect polymetallic nodules. What? They want to collect polymetallic nodules. These are a small, let's say, ball-shaped thing. So these are made of phosphorus, magnesium, etc. So they are made up of rare earth metals. They are very expensive, and so we want to develop the capacity of deep ocean exploration. And there is an agency also, like under the United Nations organization. So there is an agency which is known as International Seabed Authority. And so you might have heard about this United Nations Convention on the Law of the Sea, UNCLOS. Under UNCLOS, there are multiple organizations. One of the organization is International Seabed Authority. That International Seabed Authority, let's say, authorizes the different countries to go for deep ocean exploration. The government of India has received clearance, and government of India is doing it. Okay, that's the thing. So a lot of things are there. So we need to learn about developments and applications. Apart from this, like to understand about this particular subject, you need to do two important activities. Number one, right, you need to learn the syllabus. Learn the syllabus. Syllabus of the prelims exam and syllabus of the mains exam. In prelims, they have just mentioned general science. They have mentioned the keyword General science. In the prelim syllabus, they have given 7 different points. One of the point talks about general science. This is the syllabus of science and technology. But if you open the questions are so much deep. We will discuss about this. Questions are so much deep that it requires you to have thorough understanding of the subject. That's the thing. When we talk about mains exam, they have mentioned multiple points, okay, multiple points. So after this class, go back to your home, right, and then see the syllabus of the mains exam yourself. Learn all the points one by one. It may take 10 minutes, 15 minutes, half an hour, but this 10 minute, 15 minute, half an hour is going to be effective so much for you that, like, you will be, whenever you are reading some topic, you will be focused that I am preparing for the UPSC syllabus. It is very important that you, let's say, like, learn topics, you revise topics, you make notes. We will talk about preparation strategy as well, okay? So let's discuss about preparation strategy, okay? Preparation strategy. So when we talk about preparation strategies, the first thing that you need to do is check the syllabus of the subject, okay? Check the syllabus related to science and technology. See this syllabus of science and technology. And every subject that you read for UPSC, every subject has a different approach to learn that. I mean, like, if you are using the same approach to learn all the subjects, you will not be able to qualify UPSC. Every subject requires a different approach. And a faculty of that subject will tell you what approach you need to adopt to learn that subject. For example, the way you learn history will be different from the way you learn science and technology. It will be different from the way you learn geography. It will be different from the way you learn environment and ecology. Every subject is different in itself, and the thing is, you need to learn those subjects differently. You need to create interlinkages. You need to create interlinkages between the subjects. So syllabus is a very important thing. Then apart from this, read NCERTs, okay? Read NCERTs to clear your basic understanding related to different subjects, okay? Read NCERTs to clear your basic understanding. Apart from this, the previous year questions play a very important role. Check the previous year question of the prelims exam, check the previous year question of the mains exam, okay? Previous year question of what? The prelims exam. And previous year question of the mains exam. That will be beneficial, that will be helpful, okay? Previous year questions will be helpful. Apart from previous year questions, right? What you need to do after reading NCERTs, your preparation strategy should be in such a manner that first of all, what you need to do, you need to prepare timetable for yourself, okay? Timetable means anything that you want to read, make a written plan, write down, make your own plan of reading, and then you execute. Because anything that you do, if you are not planning for it, you will not be knowing where you are going. You understanding? Planning, why planning important? See, the thing is, we cannot do anything about the future. Planning helps us to bring future into the present and do something about it. You understanding? Means planning means we are planning to do something that we want to do in the future. So you are bringing the future, you are noting it down that this time we are going to do this. And planning will help you to streamline your preparation. That's important. So prepare a timetable. It means you need to do planning, right? Then after planning, what you need to do? You need to do reading. Reading means whichever manner. Read from the books, right? Or attend the classes that you are doing. After reading, you need to do note making. What? Note making is important. Note making, handwriting practice should be important from the beginning itself. Okay, in the classroom, whenever we are teaching some subject, every faculty makes you write notes also. Keep writing notes, because the thing is, like, every organ in our body has a capacity of learning. For example, if you are writing, your hand knows how to move in the paper. So while you will be writing mains exam, you will be writing your thing properly, okay? So you will be writing faster also. So that's important. Note making is important. After note making, there should be revision as well, okay? You need to focus on doing revision, okay? You need to focus on doing revision, that's the thing, okay? Revision is also important. So reading, note making, revision, reading, note making, revision. And after covering certain syllabus, go for writing practice also, practice test. So in the class, we are going to conduct what? We are going to give you practice test from time to time. There will be practice test for the prelims exam, there will be practice test for the mains exam. Every third week, there will be a test, okay? Every third week, there will be a test. That's the thing, okay? So this is how you need to prepare. Apart from this, there is a very important strategy that everyone should adopt, is that whenever you are reading a topic, right, prepare in a reverse manner. I mean, for example, there is a topic 1, this topic you are reading. While reading this subject, reading this paper, what you need to do, keep the interview in mind. That like, I need to interact about it with the board members. They may ask a question and I should know about this thing little bit so that I can explain it in simplest words, simplest sentences. So if you have that thing in mind, you will focus on conceptual clarity. Then while reading, make notes also. Means like, people say like we are doing UPSC preparation. UPSC preparation is not only reading, it's also making notes. The more you make notes, the more you will be knowing how to make better notes. Every day you are making notes, you will be knowing how to make better notes. And your answer structure will improve over a period of time. That's also a very important thing, very important strategy that everybody, follows. So this is the thing. Apart from this, let me help you understand some basic concepts from the area of science and technology. Let's go to another area. Let's say, let's discuss about so would you like to learn about the laws of gravitation that were given by Isaac Newton, or theory of relativity? Because theory of relativity is also very, very important. Directly, will you be able to understand? Huh? No? Okay. So, how many of you know about the laws of gravitation that were given by laws of gravitation? So, we'll quickly discuss about this, right? Later on, we'll go to understand about, let's say, further theories of relativity. Laws of gravitation. So, it was laws of gravitation were given by Sir Isaac Newton, right? He has given laws of gravitation. What is the name of the first law of gravitation? This is known as law of inertia. What? It is known as law of inertia. What is this law of inertia? The law of inertia says that every body, every object remains in its own state, either at rest or at uniform motion, okay, unless and until we apply some external forces on the object. For example, let's say if we have a ball over here, okay, this ball is kept on the ground, this ball is, let's say, kept on the ground, this is there. So this ball will stay here for long time to come, unless and until we apply some force. If we apply, let's say, some force from here, if we apply some force, so the thing is, what we are doing, we are breaking the inertia of this body, and only then this body will move, okay. Second is, let's say, this is the state of rest. This body is in a state of rest. Apart from this, if we talk about a body that is moving in this space, okay, if we are talking about a body which is moving, right, this body is moving with uniform velocity, with uniform velocity. So if this body is moving, it will keep on moving in its own direction unless and until we apply some force, unless and until we apply some force which is opposite to the direction of the motion, right? We can apply the force in this direction itself, it's going to increase the speed. If we apply in opposite direction, it's going to decrease the speed. Otherwise, it's going to remain in a uniform motion like this forever. But the thing is, in actual thing, what is happening? If you have a ball, if it is moving, after some time it will come to rest. Why? It is because of the friction. It is because of the force of friction that acts between the surface of the body and the surface of earth. Okay, friction actually brings the body, makes the body slower. If we do not have any friction, the body will keep on moving. So the first law is known as law of inertia. This was given by Sir Isaac Newton. This is law of inertia. Is it understood? Law of inertia. Apart from this, we have another law. We are going to discuss about this. This is known as law of mass and acceleration, or we can say it to be momentum. Okay, law of mass and acceleration. So under this, we will understand about momentum, as he rightly said. Okay, so we will understand momentum. What do we mean by this? Right, he used the keyword. Basically, momentum is the, let's say, force that a body can impact by virtue of the motion that it has. For a body to have momentum, it needs to have two characteristics. Number one characteristic, it should have some mass. Number two characteristic, it should have some acceleration. Acceleration means it should have some motion. Motion can be in the form of speed, it can be in the form of acceleration and all. So for example, if we have a big ball like this, using that big ball I can throw on the wall. So it's going to impact the wall. It's going to, let's say, impact the wall. It depends with how much speed this ball is hitting the wall. So, and also it depends on the mass of the ball. How much mass is there? For example, if I have a plastic ball having 200 gram, if I throw it, it's going to create some impact. If I have a ball having 5 kg weight, iron, if I throw it, it's going to create a different impact. So the thing is, the difference in impact is because of the mass of the ball and also because of speed. Why speed? For example, if you have a gun, if you have a bullet, so if that bullet from the gun is going at 200 meter per second velocity, it's going to impact the wall and it's going to maybe penetrate the wall. It's the thing. It's going to be more impactful as compared to the ball that you had, 200 gram ball you are throwing, because it has more speed. Although it has less mass, but it has more speed. So this law is known as law of mass and acceleration. Means a body will create some momentum, means like it will impart some momentum wherever it strikes, and that momentum will be directly proportional to two things. Okay, that will be directly proportional to two things. One of the thing is, it will be proportional to the, let's say, like acceleration, the force that it imparts, it will be proportional to the acceleration that the body has, and also this will be inversely proportional to the, let's say it will be proportional to the mass of the body, like that. So this is like momentum, this is known as momentum. Okay, so there are equations that are there, we'll discuss about it. Now apart from this, we do have another law. This is just for our basic understanding. The third law. This is known as law of action and reaction. What? Law of action and reaction. In short, it is known as it is known that way. What is law of action and reaction? It means, let's say, to every action there is an equal and opposite reaction. It says to every action there is an equal and opposite reaction. Okay, to every action there is an equal and opposite reaction. That's the thing. For example, if you are hitting the floor, so the thing is only floor does not, let's say, get damaged. Your hand also gets damaged. So there is a reaction also, that is instant reaction. And the thing is, this is applied everywhere. For example, if you are moving, so the thing is those athletes who, let's say, like, run on the track, so they use some kind of, let's say, like, a kind of pedal, something like this. Here they keep their hand, here they keep their feet, and they press on it. The harder they press, the more faster they will be going to the, in the direction of the motion. What they are doing, they are pushing it backside, but they are going forward. So they are making action here, reaction is happening that way. Okay, that's the thing. So to every action, there is an equal and opposite reaction. That's the thing. So this is known as law of action and reaction. This is laws of gravitation by Sir Isaac Newton. So now after this, we are going to learn about another topic. That topic will be important. We are going to discuss about it. And this year, in 2023, UPSC has asked a question. And that question was based on, let's say they asked about green hydrogen. What? Green hydrogen. So the thing is, you need to understand what is green hydrogen. I mean, like, this is just an example. We know what is hydrogen. All of us, we understand what is hydrogen. So what is hydrogen? Hydrogen is a gas, right? Hydrogen is an element, it is a gas. And how can we get hydrogen? By electrolysis of water, right? By doing electrolysis of water. We will discuss about it. But before that, let us understand about theories of relativity, okay? So this is another important area. Theories of relativity. So theories of relativity were given by Albert Einstein. Theories of relativity were given by Albert Einstein. So we will discuss about theories of relativity, right? So there are basically two theories of relativity, right? One of the theory of relativity is known as special theory of relativity. Special theory of relativity. So Albert Einstein has given a special theory of relativity in the year of, like, it was given in the year of 1905. Special theory of relativity. So special theory of relativity has two postulates. Okay, it has two postulates. I am going to discuss about that. Okay, write down about it because it's going to be very important topic, part of the syllabus itself. Write down special theory of relativity. Write down. The special theory of relativity has been proposed by Albert Einstein in 1905. After then, write down, it has two postulates. It has two postulates. Number one, the first postulate is laws of physics. Laws of physics are same for all. Laws of physics are same for all inertial reference frames. For all inertial reference frames. Laws of physics are same for all inertial reference frames. Now, to understand this, to understand the first postulate, it means, for example, laws of physics, the classical laws of physics that we have seen, right? So there we have understood about inertial reference frame. What do we mean by inertial reference frame? Inertial reference frame means, for example, let's say I do have a frame of reference. Okay, let me draw a frame of reference so that like you understand. Let's say here there is a system, there is a boy who is standing right over here in a track, and in the same track, let's say a car is moving, right? I mean like he may be on the side of the road, not hitting. Okay, so let's say the boy is standing over here and the car is moving in this direction away from the boy. So this car can move, can have different states. What are the states? Number one, the car can be in a state of rest. Okay, the car can be in a state of rest. The car can move in a uniform. It can move in a uniform speed. It can move in a uniform speed. Number three, it can move with speed which is not uniform. Means like it can have some kind of acceleration. Acceleration means the speed is changing with respect to time. So this frame will be considered to be an inertial frame of reference. Why inertial frame of reference? Because at least one of the user is either on rest or in a state of uniform motion. If this boy is in a state of uniform motion and if it has, let's say, some kind of acceleration, we will be able to identify what is the speed, what is the velocity, with what force it is going to impact the thing. So it is this kind of reference, this frame is known as inertial frame of reference. We can have any variation of the inertial frame of reference. The thing is, in the inertial frame of reference, the objects are either on rest or they are, let's say, they have some speed or velocity. There is a difference between speed and velocity. Speed means, let's say like, you are moving with respect to time, but the thing is, let's say you are going in any direction. Velocity means you are going in a uniform line, in a straight line. That's the thing. That is velocity. Okay. So the thing is, for example, if you have a track, if this is point A, if this is point B, right? And let's say there is also the thing. A person can go from point A to point B by following this path, and they can move from here to here, right? So if they follow this path, they are changing their direction. So they will, if we see the entire thing, we will consider them to have speed. If they are moving in a straight line from the point of origin to the final point, they are said to have velocity. Velocity means shortest distance cover hota hai between the initial point and the final point. Okay, we consider the shortest distance there. Okay, so this is known as inertial frame of reference. So the thing is, Albert Einstein said in one of his postulates that laws of physics are same for all inertial reference frames. This is one postulate. Then apart from this, he has given another postulate. We are going to understand very interesting things from this discussion today. All right. So second thing that he said, the speed of light in vacuum is constant. The speed of light in vacuum is constant. The speed of light in vacuum is constant and independent of the motion of the observer, and independent of the motion of observer or the source of light. Or the source of light. So this is the second postulate. So he has given two postulates. First is law of physics are same for all inertial frame of reference. Second, the speed of light in vacuum is constant and independent of the motion of the observer and the source of light. What is the speed of light? Anyone who can tell me? Speed of light in vacuum. Huh? It is denoted by C. It is 3 into 10 raised to power 8 meter per second. 23 बहुत बड़ा हो जाएगा, ठीक है? Yes? It is approximately, yes, it is approximately. I mean, like, we are just understanding approximate figure because like they have identified this after doing experiments. It is approximately this figure, okay? 3 into 10 raised to power 8 meter per second. So speed of light in vacuum is same, it remains constant, irrespective, right? Irrespective or independent of the motion of the observer. For example, light is moving and the observer is also moving. No matter observer at what speed or velocity it is moving, so speed of light is not going to change. And it is also independent of the source of light. I mean, like, you can have light from a torch light, you can have light from big thing. Speed of light will be same. It is 3 into 10 raised to power 8 meter per second. Okay, this is the thing. So these are the two postulates of the special theory of relativity that was given by Albert Einstein, and it does have many consequences. So write down from these postulates, Albert Einstein derived a number of surprising and counterintuitive consequences. Derived a number of surprising and counterintuitive consequences. Counterintuitive, intuitive. So this is counterintuitive consequences. Okay, including counterintuitive consequences, including number 1, time dilation. What? Time dilation. So we will understand about what is time dilation, right? Before that, write down this. Write down time dilation, then write down clocks moving relative to an observer. Clocks moving relative to an observer. Clocks moving relative to an observer appears to run slower. Appears to run slower. Full stop. This means that a person traveling at high speed. Will experience time slower. Than a stationary observer. Full stop. Now write down, this has been observed. In experiments with high speed particles. This has been observed in experiments with high speed particles. Let us understand what do we mean by time dilation. Okay. To understand the time dilation, let us talk about an example. Okay, let us talk about an example. Name of the example is twin paradox. What? Name of the example is twin paradox. Write down twin paradox. We'll understand about twin paradox now. Let's say this is Earth, right? Don't write down, just understand the let's say meaning of time dilation. Let's say this is Earth, where we are living on the surface of the Earth. All of us live on the surface of the Earth, not inside the Earth. So let's say there are two brothers and they are twins. Two brothers, they are twins, they are identical to one another. Let's say at this point of time they have an age, okay. Let's say I'm drawing these two brothers separately. This is one brother, this is other brother. Let's say this is twin brother 1, this is twin brother 2. Let's say they have an age of 30 years each. Means like he has an age of 30 years, he also has an age of 30 years. Both are brothers, twins, 30 साल के हैं दोनों, ठीक है. What will happen? After some time, one of the brother, let's say this brother, one of the brother, he is T1 and this is T2. What does T2 do? T2 actually goes on a spaceship, okay, he goes on a spaceship. He boards on a spaceship, and after boarding on the spaceship, he travels in the universe. He travels in the universe, and in the universe he travels with a very high speed. With a very high speed, he, let's say, stays in the universe for a long period of time. On Earth, for this particular person, on Earth, let's say this has been 20 years, let's say this has been 50 years. What will happen? 50 plus 30, what will be the age of this person? 80 years on Earth. Like he has gone, he is on a voyage, he is on Earth, like his age is now 80 years. There are places on the surface of Earth where people live for longer time. These places are known as blue zones. For example, one of the places known as, that is a fact. Apart from this is, let's say, like a kind of theoretical, paradox. But there are places on the surface of Earth where people live for longer. For example, in Japan, there is a place, it's known as Okinawa. Here people live for, let's say, more than 100 normally. People who are 95, 100 years, then every day they walk, they do exercise, they do all activities. That's the thing. There are other places also. For example, in USA, there is a place, Puerto Rico. There is, then in France, there is another place. These are known as blue zones where people have the highest longevity on the surface of Earth. So, for example, let's consider this person has gone on a voyage, the twin T2 brother, other is on the surface of Earth. It has been 50 years on the surface of Earth, but this person, since he acquired some speed, and according to time dilation, the time will appear to pass slowly for him. Means it has been 50 years for him, maybe for this person it is, let's say, 30 years. Since he is on space, he is, let's say, this thing. When he comes back on the surface of the Earth, one of the brother will be 80 years, other will be 60 years. There will be difference, right? Why? Because a person who is on speed, a person, let's say, who has some speed, he will experience the time slowly as compared to a person who is at rest. On Earth, that person is at rest. So the thing is, for him, time will pass faster. If you are at rest, time will pass faster than if you are on speed. If you are on, let's say, movement, so time will run slower. This is known as twin paradox. Are you understanding? Both were twins. They were of the same age, but while he returns, he seems younger than this person by 20 years. Means like this is just an example. This is known as time dilation. Read this statement again. It says clocks moving relative to an observer appear to run slower. This means that a person traveling at high speed will experience time slower than a stationary observer. Okay. And is there any application of this time dilation phenomena? When we talk about time dilation, is there any application? And this has been observed. It has been observed in fast moving particles. For example, we have International Atomic Energy Agency, IAEA. You might have heard about it. IAEA does have Large Hadron Collider. What? Large Hadron Collider. These are known as particle accelerators. They accelerate the particles to understand about the subatomic particles, their characteristics and all. So here, if we talk about application of time dilation, it is it is used in GPS technology. What? It is used in GPS technology. Why GPS technology? The thing is, if we talk about the satellites that we have launched, like we have launched multiple satellites. GPS satellites are used for positioning purposes, right? They are used for positioning purposes. And these GPS satellites are, if they are in the low Earth orbit, they are running at a faster speed as compared to the rotation of the Earth. Now, like when we discuss about the space technologies later date, you will understand that let's consider this is Earth. Once again, I'll use blue color so that you associate blue color with Earth. Let's say this is Earth. Like there are orbits where satellites are launched. So we do have geostationary orbit, we have geosynchronous orbit. What are geostationary orbit? Geostationary orbit are a specific case of geosynchronous orbit. What happens in geostationary orbit? Generally, let's consider it is at a distance of 35,676 or approximately, let's consider approximately this is at 36,000 kilometer distance from the surface of the Earth, approximately. So those satellites that are placed, let's say like in line with the equator, the satellites that are placed in line with the equator, these satellites, let's say like revolve around the Earth at the same speed at which Earth rotates around itself. So from the surface of the Earth, that particular satellite seems to be at a stationary place. That's why we call this orbit as geostationary orbit. Then we have geosynchronous orbit. In geosynchronous orbit, we place the satellite at the same distance, but not along the equatorial line. We place anywhere else, but at the same distance. That is known as geosynchronous orbit. Then the thing is like, so they will be rotating at the same speed. All those satellites that are placed near to the geostationary or geosynchronous orbit, right, that are placed near to this. Those satellites that are placed, let's say like, at a distance less than, let's say 2,000 kilometer. At a distance less than 2,000 kilometer, they are known as low Earth orbit. What? They are known as low Earth orbit. You might have heard about International Space Station. We have International Space Station, right? India is not a member of that thing, but there are 5 space agencies, like, from different countries, USA, then we have UK, Russia, I think Canada is member of it. Means like various space agencies are member of it. They have an International Space Station. That International Space Station is at a height of 400 kilometers from the surface of the Earth. How much? 400 kilometers from the surface of the Earth. And that satellite is revolving at a very fast pace as compared to the rotational speed of Earth. So here the speed will be very high. If speed is very high over here, if we have atomic clock over here in this particular satellite, that clock will experience time slower as compared to the clock that is there on the Earth. Are you understanding this? So the thing is, in GPS technology, we find application of time dilation. We continuously keep on, let's say like, like adjusting the time. In satellites, we have atomic clocks, and those atomic clocks are adjusted, right, on a regular basis, so that like, they are in sync with the time on the Earth. And if we talk about the satellites that are revolving beyond 36,000 kilometers from the surface of the Earth, those satellites will be moving slower as compared to the rotation speed of Earth. So those satellites will see time dilation, means there the time will pass what? Slowly as compared to time on Earth. For those satellites also, we need to keep adjusting the time. And when we talk about India, India does have a system which is known as Indian Regional Satellite Navigation System, IR and SS, that has been renamed, and its name is now NAVIC. It is known as Navigation with Indian Constellation, right? Navigation with Indian constellation. Under that navigation with Indian constellation, we have 3 satellites that are placed on geostationary orbit, and we have 4 satellites that are placed in geosynchronous orbit. So we do have those satellites that are placed, and we need to keep on adjusting the time of the atomic clocks that are there on the satellite. So the thing is, time dilation finds its application in GPS technology. Is it understood? Time dilation finds its application in GPS technology. There we have atomic clocks, and we need to keep on adjusting the clocks from time to time. Not every day, but like, from time to time we keep on adjusting this thing. In a similar way that, on Earth, for example, the Earth is revolving around the Sun. We are completing one revolution in 1 year, 365 days, 4 hours. And how do we adjust it? Leap year. For example, this year, I think 6 hours. This year, we have a leap year. We have 366 days. In this year, 2024, it's a leap year. We'll be having 29 days in February this year. Are we understanding? So that's how things are connected. So we need to, let's say, connect the things. We need to understand this. So is this twin paradox understood? Yes.
In this, we are comparing the revolutionary
Rotation.
rotation speed of Earth with revolution of
Satellite around the Earth.
the Earth.
Means like those satellites that we are sending, most of the satellites that we are sending, they are either remote sensing satellites or they are communication satellites, right? So using those satellites, those satellites are revolving around the Earth, and that's why we need to keep adjusting the timing of the satellites.
So they revolve around the Earth in 24 hours.
Those satellites that are placed on geostationary orbit, they will revolve around the Earth on after 28 hours, and they will seem to be stationary from the surface of the Earth. But there are satellites that are known as geosynchronous satellites. They are placed at the same distance, but they are not placed on the equatorial line. Equator, all of us understand? Equator, this is Earth, this is the middle line, this makes 0 degree latitude. On the top of this, there are other lines up to 90 degree latitude, north, and there will be other lines to the south. We will be having 90 degree south, like that. These are known as lines of parallel. They are known as latitudinal lines. Similarly, we have longitudinal lines. What? We have longitudinal lines like this. Why longitudinal lines are important? Longitudinal lines help us to identify the time zones in different countries. For example, all of us have understood about Greenwich Mean Time.
Longitudinal lines converge at the poles or no?
Huh?
Longitudinal
They will converge at the poles like this. ऐसे होता है, but for our understanding, to make it simple, I have drawn this way. So the thing is, they'll be converging. Here we need to understand longitudinal lines, why they are important, because they help us to distinguish the time zones. Why time zones? Because Earth is revolving, one thing, Earth is receiving the sunlight. Let's say if sun is here, Earth is here, if it is rotating, what will happen? Some portion of the Earth will receive sunlight, other portion will not be receiving sunlight. The portion that receives the sunlight at a particular point of time, there will be day. The earliest time when we receive the sunlight, that will be the morning. The latest time, that will be the night, like that. So the thing is, it is important that we synchronize this particular thing. So that's why different countries in the world has different timing. For example, India is 5.5 hours ahead of the Greenwich mean time, like that. In India, we have only one time zone, right, which is known as Indian Standard Time. But the thing is, there have been suggestions also for India that, we create 2 time zones. So, for example, meanwhile, if you have any questions, keep asking your questions so that I can make those things clear to you. Yes.
Sir, I can't understand Greenwich time.
Okay. This is just a rough map. Okay. Here.
Is there any specific application of geostationary
Yes. Huh.
because it is an equator and the synchronous one are not. So
I'll talk about that. I'll give you a specific example where we use geosynchronous satellite, where we use geostationary satellite. See, today is just a kind of introductory class. We are not discussing in detail. I'm just giving you overview. When we discuss in detail, we will be covering one topic in so much detail that you will understand multiple dimensions of it. Here it is possible that you may not understand some of the things because I'm covering the topic from, let's say, like, from outside in that manner. So let's say this is India, rough map of India. So the Indian standard time that is there, that passes through, like, a line like this. So there is a line that is known as Indian standard time. And the thing is, over here in this particular line, UPSC does ask question, how many states, through how many states the Indian standard time passes? 5 states, 6 states, remember the name of these states. That's from the geography point of view. Okay, in India, we only have one time zone which is known as Indian Standard Time, which is plus 5.5 hour as compared to Greenwich Mean Time, GMT. Greenwich Mean Time is, let's say, on the surface of the earth, the place where sunlight happens for the first time. Like, they have synchronized the clocks on earth, clocks 24 hours होते हैं. उस clock के हिसाब से जहाँ पे सबसे पहले आता है sunlight, वो जो है that place, like it passes through England. जैसे अगर if we talk about the globe, this is globe. ग्लोब में देर इज अ प्लेस, यहाँ पे मतलब सनलाइट सबसे पहले होता है. वो उस लॉन्गिट्यूडनल लाइन को ग्रीनविच मीन टाइम बोलते हैं. एंड ग्रीनविच मीन टाइम जो है बहुत स्ट्रेट लाइन नहीं है, समवेयर इट इज लिटिल बिट कर्व्ड ऑल्सो. ये ओशनिक रीजन में वहाँ पे थोड़ा सा कर्व्ड भी है. इट्स लाइक दैट. ठीक है, इट इज रेड अंडर ज्योग्राफी एज अ सब्जेक्ट. ठीक है, ग्रीनविच मीन टाइम के हिसाब से हमारे इंडिया में सन मॉर्निंग कब होता है? 12 बजे नहीं होता है रात को, सुबह 5:30-6 बजे के आसपास. लाइक इंडिया हैज द एक्सपेंस फ्रॉम वेस्ट टू वेस्ट टू ईस्ट. ठीक है, अराउंड 34-37 डिग्री टोटल है. तो इसमें क्या है कि सन मॉर्निंग होता है सबसे पहले, किस रीजन में सबसे पहले मॉर्निंग होता है? ईस्टर्न वाला या वेस्टर्न वाला? ईस्टर्न में सबसे पहले मॉर्निंग होता है, फिर धीरे धीरे इधर मॉर्निंग होता है. इट्स लाइक दैट. सो देयर इज अ टाइम डिफरेंस, बट लाइक वी हैव सिंक्रोनाइज्ड द क्लॉक अकॉर्डिंग टू IST. लेकिन क्या है, ग्रीनविच मीन टाइम में जब सनलाइट पहली बार आता है मॉर्निंग में, उसको 0 आवर कर दिया उन्होंने. ठीक है, अकॉर्डिंगली हमारा इतना आगे है. इट इज लाइक दैट. दिस इज फॉर दैट पर्पस. अभी समझ में आया? सिंपल चीज, सिंपल अंडरस्टैंडिंग. दिस इज द थिंग. तो क्या वो देख लो. ठीक है, ग्रीनविच मीन टाइम कहाँ कहाँ से पास होता है. It's like that. There is a line, there is a timing. ठीक है, उधर से ही मतलब like it happens. But like there is a region nearby England also, I think, like Eastern England is there in the, let's say, like the Western country, and then it is Eastern. So Eastern मतलब New Zealand वहाँ पे. So you see it geography में. ठीक है, this is just for understanding of the Greenwich Mean Time and the time zones. So this is how it happens. So we were talking about the time dilation. ठीक है, तो टाइम डायलेशन इज अ थिंग विच इज इन रियल एंड इट इज अप्लाइड ऑल्सो इन GPS टेक्नोलॉजीज. ठीक है, फॉर एग्जाम्पल लाइक वी हैव सेंट आदित्य L1. फ्रॉम आदित्य L1 वी आर कॉन्टिन्यूसली कम्युनिकेटिंग विद इट, वी आर रिसीविंग डेटा फ्रॉम इट. वहाँ पे भी क्लॉक होगा, हर एक चीज़ में क्लॉक डालते हैं वो, सो दैट लाइक टाइमिंग का पता लगे. बिकॉज लाइक वी आर सेंडिंग इट, तो कितने दिन बाद वो वहाँ पे जाके पहुँचेगा. इट टुक अबाउट 4 months आई थिंक, right, for Aditya L1 to reach there from the surface of the earth, right? So exact timing you need to see. ठीक है, 110 या 20 days के आसपास है total journey, space time journey. Okay, this is the thing. So is this understood? Time dilation, concept of time dilation. Then there is another thing which is known as length contraction. Okay, this is a kind of consequence of special theory of relativity. This is known as length contraction. Length contraction. This is the second consequence of special theory of relativity. Special theory of relativity was given by Albert Einstein in the year 1905. Okay, write down this thing, length contraction. Objects moving relative to an observer. Objects moving relative to an observer. Objects moving relative to an observer appear to be shorter in the direction of motion. Shorter in the direction of motion. Full stop. This means that a fast moving object will appear shorter than the same object. I am repeating. This means that a fast moving object will appear shorter than the same object at rest. This means that a fast moving object will appear to be shorter than the same object at rest. Write down, this effect has also been observed in experiments. This effect has also been observed in experiments. Length contraction में क्या होता है? So write it down. This effect has also been observed in experiments. Now let us understand what happens in length contraction. So generally, let's say there is an object. Okay, there is an object. It may be. Let's consider this object to be a car. Okay, this is an object. I have made a bigger car. So if this car is at rest, what will happen? This car will appear to be larger to us. If it is at a motion, let's say like, if it is moving, right? If it is at motion, very high speed, right? It will appear, it does not mean that its height will get reduced, right? It will appear to be shorter than its actual size, okay? It will appear to be shorter. So a fast moving object always seems smaller as compared to an object which is at rest. This is known as length contraction, and this has been observed in particle accelerators. I discussed about Large Hadron Collider, which is there in International Atomic Energy Agency. So they accelerate the particles at very high energy levels, and they observe the characteristics of those particles. And in the particle accelerators, they have identified that they showcase time dilation, they showcase length contraction also. Okay, this is the thing. So after this, is it understood? This is very simple. Second one. After this, we have third. This is known as mass energy equivalence. Write down mass energy equivalence. Mass energy equivalence. Write down E equals to mc square. E equals to mc square. स्क्वायर का मतलब होता है कि c को हमने दो बार मल्टीप्लाई कर दिया, ठीक है? c इंटू सी इज सी स्क्वायर, x इंटू एक्स एक्स स्क्वायर, लाइक दैट, ठीक है? दो बार मल्टीप्लाई करते हैं तो स्क्वायर बनता है, तीन बार मल्टीप्लाई करते हैं तो क्यूब बनता है, लाइक दैट, ठीक है? E इक्वल टू एम सी स्क्वायर. आफ्टर दिस राइट डाउन हियर वेयर E इज एनर्जी. E is energy, M is mass, E is energy, M is mass of the object, and C is the speed of light. C is speed of light. And what was the value of C that we discussed? It is 3 into 10 raised to power 8 meter per second square. This is approximate value, okay? E equals to mc square. So Albert Einstein has given this formula. He said mass can be converted into energy and energy can be converted into mass. And he has given a formula E equals to mc square, means a small amount of mass can be converted into huge amount of energy. Small amount of mass can be converted into huge amount of energy, क्योंकि mass को हम c square से multiply करते हैं वो बहुत बड़ा बन जाता है, that is the thing. And energy can be converted into mass. And this thing is used to understand about the origin of the universe, how the universe has originated. The atom bomb that we discussed, right? In atom bomb, what happens? Like, you have very small quantity of radioactive elements, and when they split, they generate huge amount of energy, right? For the first time, atom bombs have been used in Hiroshima and Nagasaki, right? Name of the project? Manhattan Project. Who headed that project? Oppenheimer, right? Oppenheimer headed that project. And every other country in the world, they are acquiring, in the race of acquiring nuclear weapons. Why? Because they want to make themselves stronger. They want to increase their deterrence posture. India is a nuclear state. India has nuclear power, right? We are a nuclear state. We do have nuclear weapon. China is a nuclear state. Pakistan is also a nuclear state, right? North Korea is a nuclear state. USA is a nuclear state. Then Israel is also a nuclear state. Israel is a very small, it is a nuclear state. That's why other countries are only saying it, that go for ceasefire, do not do genocide. Other countries are not attacking on it. Iran is totally against of Israel, but Iran is also not attacking on Israel, because Israel is a nuclear state, Iran is not yet a nuclear state. Iran was increasing its nuclear capacity. There have been, let's say, the US president has interacted with Russia, Iran. They have gone for civil nuclear program in Iran. But the thing is, Iran wants to develop nuclear capacity. Okay. USA considers Iran to be an adversary for itself, like that. It considers North Korea to be an adversary for itself. That's the thing. So we will write down something about it. So you have written that c is the speed of light. Write down, this equation shows that mass and energy are interchangeable. Mass and energy are interchangeable, and that a small amount of mass can be converted into a large amount of energy. So now write down heading applications of the special theory of relativity. Applications of the special theory of relativity. So where do we find applications of a special theory of relativity? Number one, GPS technology that we have discussed, right? Just write down GPS technology. Second, here write down GPS technology के आगे लिख लो, मतलब write down so that you understand in detail about it. So write down, GPS satellites have atomic clocks. That are synchronized with clocks on the ground. Full stop. However, because the satellites are moving relative to the earth, relative to the earth, comma, their clocks experience time dilation. However, because the satellites are moving relative to the earth, their clocks experience time dilation. Their clocks experience time dilation and appear to run slower than the clocks on the ground. Full stop. If this effect were not taken into account, comma, GPS measurements would be off by several kilometers. Full stop. Write down second area of application. Particle accelerators. This is second area of application. Particle accelerators. Write down the high energies involved. In particle accelerators result in relativistic effects, comma, such as time dilation, relativistic effects such as time dilation and length contraction. Now write down, full stop, these effects must be taken into account in the design and operation of the accelerators. Write down next point, nuclear energy. We are understanding the application of a special theory of relativity. Third, nuclear energy. Write down the conversion of mass into energy. Comma, as described by the mass energy equivalence equation. Which is E equals to mc square. In bracket write down E equals to mc square, comma, write down is the basis of nuclear energy. Written? Okay. Full stop. Now write down, nuclear reactions involve the conversion of a small amount of mass into a large amount of energy, into a large amount of energy. Into a large amount of energy. Anything missed? Okay, written. Okay. So now see what we have understood. We have understood the special theory of relativity. So in a special theory of relativity, Albert Einstein has given two postulates, and out of these two postulates there are consequences. These consequences are counterintuitive effects, right? So these effects are time dilation, length contraction, and mass energy equivalence. Time dilation we have understood through twin paradox. Length contraction we have understood easily, right? Then mass energy equivalence. All the nuclear energy programs in the world that is there. For example, in India, we have huge number of nuclear power plants. One of the nuclear power plant was recently in news, which is there in Gujarat. So in Gujarat, I think Kakrapar nuclear power plant. So like one of the nuclear power plant was in news. So they have operationalized the second unit of the nuclear power plant. They are working on the third unit. So in India, we have a 3-stage nuclear program in India. Okay. So that 3-stage nuclear program in India has been given long back by Dr. Homi Jahangir Bhabha, and there were, let's say, like, contribution of Dr. APJ Abdul Kalam also. So we will discuss later on about the nuclear technology. So we do have, let's say, like, we are going to discuss about the nuclear technology or nuclear science. There we are going to understand about lot of things. So when we talk about nuclear technology, they are considered to be dual use technology. What do we mean by dual use technology? Using nuclear technology can be used for civilian purposes. For example, for the generation of electricity. We do have nuclear power plants in India. There are many countries that have nuclear power plants. So nuclear energy is used for generation of electricity, which is going to be used for civilian purposes, for providing, for meeting the energy demands and energy needs. But at the same time, nuclear technology can be used for creating nuclear weapons. So it does have military applications also. Okay, it does have military applications. For example, India is a nuclear state. Nuclear state means India is a nuclear weapon state. Pakistan, China, North Korea, then like USA, right, UK, these are nuclear weapon states, right. So the thing is, nuclear energy can be used for making weapons also, they can be used for generation of electricity as well. Whenever we are doing it for peaceful purposes, it is known as civilian use. Whenever we are using it for defense purposes, this is military use. So nuclear technology is known as dual use technology. What? It is known as dual use technology. Similarly, we do have various technologies that are considered to be dual use technologies. Okay, we will understand these things, let's say, slowly and gradually. So this was one of the thing which is known as, let's say, the special theory of relativity. Apart from this, Albert Einstein has also given another theory of relativity, which is known as general theory of relativity. He has given general theory of relativity in the year of 1915, after 10 years from this timing. Okay, and as part of general theory of relativity also, like, there are many counterintuitive effects. For example, like the effects, for example, gravitational lensing, gravitational waves, gravitational time dilation, right. These are some of the counterintuitive effect of, let's say, general theory of relativity of Albert Einstein. Maybe in the next class when we have, that time we will discuss in detail, because the general theory of relativity is going to take time, similar to, like, the special theory of relativity has taken. And apart from this, let's say, science and technology is a subject. If you understand it deeply, you will understand about why something is being done, what are its applications, and why we need to learn about it. Okay, so like you need to relate it, and the thing is, like, there are many questions that UPSC asks every year. You need to read some basic books, NCERT books. Okay, what I am going to do, like all of you, for example, I am going to create a, let's say, a PDF document. I am going to share the name of the book, NCERT book, and I am going to share the name of the chapters that you need to read from NCERTs. Okay, So there are some specific books, and from those books you need to read some specific chapters. You don't need to read all the NCERT books from 6th to 12th. That's not going to be beneficial, and reading that will be very difficult for those people who are from non-science background. If I ask you to read, let's say, physics of 12th standard NCERT, you will not be able to understand many things. If you open the chapter on electromagnetic waves, it's so difficult, like you will not be able to understand. So the thing is, that has to be taught in the classroom, and in the classroom, the topics that we discuss not from the, let's say, like point of view what is there in the book, but from the view of the exam, like what is needed in the exam. Sometimes you may have to learn the topics from, let's say, a post-graduation point of view, so that like you have proper understanding on the topic. Sometimes a basic understanding will be sufficient. NCERT level understanding will be sufficient. That's the thing. For example, if I talk about, write down a question, very simple question, UPSC has asked in previous year from science and technology. I hope you will be able to answer that question after this. Write down this question quickly. Prelims question. Which one of the following is a reason, R-E-A-S-O-N, is a reason, which of the following is a reason why astronomical distances are measured in light years, Write down options. Okay, so write down 4 options. So write down A option here. Distance among stellar bodies do not change. Distance among stellar bodies do not change. B, option B, write down. Gravity of stellar bodies do not change. Option B was gravity of stellar bodies do not change. Option C, light always travels in a straight line. Option D, speed of light is always same. Option D, speed of light is always same. So written all these options. UPSC has asked in the previous year, guess what should be the answer? Very simple question. So is the question written properly by all of you? Yeah. Guess what is the answer? Option D, speed of light is always the same. Where did this statement come from? Albert Einstein, special theory of relativity, the second postulate, right? So the thing is, UPSC is asking previous prelims question of this level. If you have understanding, you will be able to answer. Otherwise, all these statements seem to be equally valid. It says, first statement it says, distance among stellar bodies do not change. Is this correct? No. Because the universe is expanding. Like, when we talk about how the universe took birth, what is happening now the universe is expanding. Okay, we will discuss about that thing in the general theory of relativity. Okay, that's the second. Gravity of stellar bodies do not change. This is also wrong. Why gravity do not change? Because stellar bodies, for example, if we talk about the sun, on the surface of sun, lot of reactions are happening. Sun is continuously losing energy, right? Since it is losing energy, it is also losing mass. Since it is losing mass, its gravity will change, because gravity depends on the density of a body, right? Density of a body, that's the thing. Okay, so that we will understand. Second is also wrong. Third says light always travels in a straight line. This is also wrong. We understand this thing in 10th standard when we read about ray optics, when we talk about reflection, refraction, like that, when we read about mirror lenses, then we understand ki light travels in a straight line path. But that's to make you understand, to simplify the thing. But the thing is, when you come to 12th standard physics, you learn about Huygens principle, right? Huygens has given principle. He talked about wave front, that every light, every wave front generates secondary wavelets, which in itself act as like wave fronts for the next light. It is like that. So light does not travel in a straight line. Okay. So this is the thing. And the thing is, there is when we talk about quantum mechanics, so we talk about the duality. Sometimes the light assumes particle nature, sometimes it assumes wave nature. So the thing is, first three statements are wrong. Like we need to discuss in detail so that you understand, otherwise it may seem little difficult at this point of time, but when we have regular interaction, when we will be having classes, right, so you will understand about these topics properly, you will understand the concepts. Sometimes you may face difficulty, but that time I will be available, you can come and interact with me. That's the thing. So any questions from you, any one of you? Questions from the topic you have read, from the areas that you may be having in mind. So from now onward, every day there will be a class by a specific faculty from Lukmaan IAS. You can attend all those classes whether you have joined or not joined, right? It was considered to be an open session, right? All these classes, and later on we are going to start with Indian economy. And economy is also a subject where you need to focus on current affairs apart from the basics, right? So that's the thing. So, yes, so if you have questions, you can ask me. There are many topics that are interrelated, interconnected. When we start discussion, so we will discuss all aspects in a very broad and deep manner, so that after class, you are not left with any doubt. So if you come across question, you will be able to reason out that this is why this thing is there. Yes. Any question?
You said in the start if there is a question between asking the difference of Newton law and the laws by Albert Einstein. So we will write about general theory or special theory?
Both. We will talk about that the laws that were given by Sir Isaac Newton, they are known as classical laws of physics. And the thing is, when we talk about the laws that are given by Albert Einstein, right, they are known as modern physics. They are part of modern physics. Especially the general theory of relativity and quantum physics, they are part of quantum mechanics. They are part of modern physics. So we can summarize it within a minute. If you know more, you can explain more. Otherwise, let's say you can say little. That's the thing. So they asked this question, they have asked many questions, here in the institute, I'm looking after the interview guidance program. So we do have board members who are former bureaucrats. They're taking interviews of the candidates. I do interact with the, let's say, means qualified candidates daily, regularly. So we understand the thing, okay. So the thing is, you need to develop scientific temper. You need to reason out the things, why this is there. Now, before going, I will be giving two questions. I'll be asking, how many time zones do we have in United States of America? Factual, simple, if you know, otherwise you don't know. United States of America is a very big country, right? So they do have, let's say, geographical expanse very high. So it has 5 time zones, USA. How many time zones do we have in Russia? Yes. 3, 7, 9, yes. Any other guesses? Russia has 11 time zones. Okay. So those countries that are big geographically, they have different time zones because because they have to somehow synchronize it with the natural thing, with the sun. Okay, that's the thing. So this is the thing. So that will be all from my side for the day. I think outside there will be some document, current affair from science and technology area. I have been teaching the current affair also of this subject and science and technology in the GS Foundation batch. Apart from this, I take the Hindu newspaper analysis daily. I do take discussion every day, so you can attend that discussion, right, if you wish to. And we cover a mapping topic every day in the beginning. So that will also help. Right. So this is the thing. However, the current affair discussion that we have, they are very fast. I mean, because students want to cover as soon as possible, that's the thing. Okay, so maybe today's current affair you may watch if you get time, right, after going home. But like we'll be continuing the current affairs session also, and tomorrow onward there will be classes of other subjects, and those students who are attending online, they will receive the link the way that they have received for today's lecture. And so we will share the plan, lecture plan also, and I will be sharing a PDF document having name of the NCERT books and the chapters that you need to read, and I will give the link of the chapters also. You can download the soft copies from the internet. So the thing is, like, NCERT maintains a website. From there you can download the PDF book, you can download and read from there. Okay, so whenever science and technology will come in the discussion, that time we will discuss in detail this subject. All right, so thank you so much. Thank you everyone.
So what will be the subject for tomorrow?
Tomorrow, just